Okay, we might get started. Can everybody online hear me? Yep, there's a thumbs up. Great, fantastic. Thanks for those of you who made the effort to come along in person. I know it's pretty windy and cold outside. And thanks for those who have made the effort to log on online. So this is the Retrofit Forum on location. We're actually 4 floors lower than we normally are from the Japanese room down in the gallery, exhibition gallery at Melbourne School of Design. And that's because around me, as you can probably see, is the Retrofit exhibition, which has been going on for over a month now. We have a great agenda today on AI and data-driven insights for Retrofit. Just before we get started, I'd just like to acknowledge the traditional owners of the land, the Wurundjeri Woi-wurrung people of the Kulin Nation. Unceded lands, we appreciate their custodianship and care in looking after them previously and continuing to do so. And these proceedings are in the spirit of reconciliation. And I'd like to pay our respects to elders past, present, and importantly, emerging. So today we have Dr. Yang Zhao, a senior lecturer in digital construction from the University of Auckland. Thanks for coming over, Yang. And we also have Zhen Zhang, a PhD student, come over as well. Great to get some diverse geographical opinions, as well as Yang and Zen. We have Alice Kosminas and Maz Gassemi Chukaboni from another PhD candidate from University of Melbourne. Alice is an associate professor from FATE, Engineering and Information Technology. So as usual, we have 2 sort of 15 to 20 minute presentations, which are reasonably close, but not quite so close that it doesn't create a little bit of overlap and some questions that come out of it. So I'm really looking forward to it because BIM is such a big thing in industry, and I've been out of industry for 7 or 8 years now, and I feel like I'm losing touch. So I'm quite keen to try and get back on the cutting edge somewhere. As usual, we'll leave 5 minutes for what's going on in Retrofit around the traps at the end. Hopefully we'll have some healthy question and answer time. Yang, I might ask you to present first. Is that okay? Yep. Do you want to take over the sharing of the screen?
That's all good. Yeah. All right. Thank you, Brendan, for the introduction. Hello, everyone. My name is Yang. So I'm currently a senior lecturer at the University of Auckland. My research expertise is in digital construction. I think today the topic I'm gonna present is a little bit like more general knowledge management, but I think it also relates to retrofit. So I have to just give in the technical, I think the credit to my PhD student, Zhen Zhang. So he's the student who drives the technical development of the project. So I think today I would briefly introduce, I think, 4 points. The first point is that why do we need to just learn from the past, especially some incidents and some valuable lessons in the built environment. Secondly, I would like to give a brief introduction on the ongoing project. What we have doing is to unify the large language models and also ontology to improve the knowledge sharing, knowledge reuse. And then after that, I will just reflect on how these technologies and also the knowledge sharing concept can be extended for retrofit. And then I will use another maybe 20 seconds to briefly conclude my talk. Okay, so to start with, I think this is a bridge collapse incident. So it happened in 2018 and killed 48 people. So I think this is only one of the incidents that we have maybe had in the past few years. But with the climate change, there have been a lot of like uncertainties that may be threatening our built environment infrastructure systems. But the incident may be caused by some design errors, by a lot of maybe some problems, maybe with the construction quality, and also possibly the lack of the proper inspection and maintenance. But actually, if you look at this, so you will see that actually in the construction life cycle, usually what we record and pass the information is actually only is above the sea level. But most of the knowledge, for example, why we make decisions during our design process, actually has not been well recorded and also communicated during the life cycle of our projects. So if we're also looking at the different formats in our built environment project, we have a lot of those graphical data, so pretty much in building information modeling or GIS format. But we also have a lot of those non-graphical data like emails, documents, a lot of PDFs, right? So, and then some of the structured data like databases, bills of quantities. But I think the most significant challenge for our engineers is that this data cannot be processed by the AI, by computers very efficiently. And the data exchange is also a big issue. But if we're also looking at conceptual level, so there are different, so if we're thinking about linked data, so there are different levels of the understanding about information data. So for example, so for data itself, it could be some numbers like 100, but without any specific real world meanings. But if you go beyond that level, so information means, for example, we can define the 3 meters is the dimension, and then most of our engineering documents and then our existing tools can only capture the data and information, but not knowledge. For example, the knowledge means that we can link those individual data, those points with relationships. So for example here, so when we define a panel size, it's 18 meters special lifting equipment required in assembly. So at this moment, I think with the power of emerging technologies, we are more moving towards from the capability of understanding and processing data information to understanding and recording and also sharing our knowledge in a better way. Especially if we think about the traditional lesson learning or knowledge sharing process, we have a lot of traditional documents like PDF. We organize workshops, we write those incident reports, but it's very low efficient and also causing a lot of like a misunderstanding. Especially if those documents are written in PDF and in paper-based way. So it's very difficult to retrieve the information accurately and fastly. Now, this is the beauty of the world. We have, I think after 2020, so we have large language models. So large language models positions with this level in deep learning, but also had some overlapping with generative AI. With large language models, it provides it enables us to process millions of documents, especially texts, in a fast and intelligent way. But if you use large language models, you will find large language models actually have a lot of problems. It cannot be used as an expert. It can possibly only give you some superficial information. And also, it also cannot be flexible enough to adapt changes because, for example, ChatGPT, the training data set was pretty much 2 years ago. The third is that it cannot generate information precisely. You will generate a lot of those information that you don't want to, you will find useless. So the last challenge is that, for example, it can generate text, can improve your emails, but it cannot generate your building design, models, drawings. So a lot of those challenges. So to address the challenges, especially the information retrieval. So there have been a couple of ways. Data injection, for example, we can enrich our prompt to be more detailed, but it has definitely context size. You can, for example, some engine cannot allow you to have more than 2,000 words. The other way is fine tuning. So you can modify the existing large language models and then to train the model with some domain data. But the challenge is that you will need millions of money to do this part, and also the data in our built environment is still limited. So I think more realistically, we have to use the retrieval augmented generation. So which means that so there are also three ways: vector-based, hybrid, and graph rack. So what we think, which is very realistic for engineering and built environment, is that we combine the traditional vector-based, which processes the documents. So processes the tokens, words in the document as vectors to calculate the cosine similarity. And then another way is that to convert those structured documents into models. I think a good way is that we combine the two as a hybrid RAG. So that we can process both the structured data and unstructured data. So based on this understanding, so we have developed a prototype. So for query and ask in just for engineering use. So the beauty of the things is that we can leverage those large language models, whatever you use, DeepSeek, ChatGPT, GimLink. But in the meantime, so this hybrid RAG can enable us to also access and retrieve information from our structured and unstructured data. For example, some design codes, also some of the ontology models we have developed, and also some other existing ontology models. So for example, so for connection design is a main challenge for steel structures, especially like complex stadiums. So usually you have different ways to design the connections. So what we think is good is that we can convert those design data into structured format, so the computers can process it because it defines the entities, attributes, and the relationships. So when we want to use it, so we can run the large language models to access those well-defined ontology models and related documents and design models and so on. So we have a demo to show how the system works. So to use this online prototype, so we definitely have already just behind this user interface, we have already created, for example, our connection ontology and some data set. So this domain knowledge will support us to augment the retrieval power and capability of using the large language models ChatGPT. So you can see that actually the system itself runs, can give you the answers very promptly. So I'm not going to just finish the whole thing, but you can see actually you can accurately retrieve those documents, and also more importantly, we can also retrieve those information. For example, some design parameters and key attributes from the documents very accurately. So this is very different from the traditional document search engine. Okay, so to evaluate the performance of the system, so we have generated random questions to try whether our system performs better than the existing large language models. So you can see by using the hybrid RAG and also large language models. So the orange bars shows that our system can definitely significantly enhance the information retrieval and query accuracy. So how this might relate to Retrofit? So we think that we have a lot of those fundamental needs like survey, maintenance, inspection, survey, but through the knowledge base, it can help our end users to find the, for example, valuable cases and information in a very fast way. So this can also enable us, for example, to do some retrofit design to have more real-time interaction with our design tools and also the existing knowledge base. So for example, I think thank you so much, Brendan, for suggesting me to find a case. So this is actually our beautiful campus, and then this is our new engineering building for the University of Auckland. But the complexity of this is that this existing building was built like more than 50 years ago, and it's still pretty much an old concrete building. And then the university was planning to build a new one. This is the a structural frame building, 12 levels. So because in New Zealand, I think we have a lot of earthquakes, natural disasters. So how to connect the two parts is definitely a challenge. For example, by connecting the two parts, so we have a lot of the so the knowledge that have not been well documented, for example, how we engage with the stakeholders and how to design the connections to making sure that the both new buildings and also the connection part can stay well safely against any earthquakes, and then and also how can we just make the part maybe waterproofed. So I think all these things can be very valuable lessons for new projects. So I think that's something that I think in the future when we have large language models, so we can easily revisit some of the past lessons and then to improve the design, retrofit, and also different purposes for our engineering projects. Okay, so to conclude, so through our proof of concept project, so we have seen that large language models and AI is definitely coming and is very realistic for engineers and for researchers to use. But definitely in built environment, we also have a lot of challenges. For example, in civil engineering, in smart city, urban planning, still a lot of authorities, they don't want to share data, which means if you want to train your large language models with domain-specific data, you will find the data scarcity or availability is a big issue. The second is that the current large language model still lacks of capability in processing models and some engineering different formats and some other non-structured data formats. So this also kind of hinders us of using these learning-based approaches in our retrofit and also the construction lifecycle. So that's pretty much my presentation. I hope this is kind of like useful to facilitate some discussion. Thank you so much.
Thanks very much for that, Jan. Alice, do you want to set up? We usually hold questions off to the end, but
No problem.
Just while Alice is setting up, I'll sneak one in if that's right. When you say limited by the information pool, so is this publicly available information, or is this
so for the connection design?
Well, yeah, I'm thinking of all engineering. I'm wondering if there's scope. If I was an engineering company, I'd want to perform AI on the pool of information I have within my company, and maybe there's other like-minded companies that I would join together. So you create a platform of a certain type of structural engineer, so to create a base of data that's more reliable than just
Exactly.
out there public data.
Yeah, I think for large firms like Arab or WSP, then because it's global firms, we have a lot of like engineering design projects and data available. So I think one of the realistic ways that we set up the local large language models and using the companies owned data to train the large language models. It's costly, but it's doable.
Yeah.
But just needs some a very well designed process to do this. But for small and medium and small enterprises, so I don't think it's doable. And also the data, I think the IP, because for large companies, they don't want to share their IP with their
Yeah.
competitors. So data IP, data security is also another concern for most of our designers and also practitioners.
Well, that's where my question was leading. The valueness
Yeah.
on that data is really high. So
Yeah,
yeah, that's the edge a lot of companies have. And if all of a sudden, everyone
Yeah.
can get that data, or
Yeah.
even a bigger group can get that data,
yeah,
you need
But
to
I
think
think
about
still
the
people have
commercials.
fear of sharing data,
Yeah.
because it relates to liability and
Yeah.
then and the
Mm.
data might be owned by different stakeholders as well.
Yeah. All right. Sorry about that. Alice, how are you going?
Yeah, I'll just stop sharing. Um,
Yeah, thanks, Brendan, for having us here today, and thanks to Yang for I think you've explained it all so well that my presentation might actually make a bit more sense. So that's great. I'm here today to present on a tool that was developed as a result of a collaboration that we have had in the last year with the Retrofit Lab. So I'm from the Faculty of Engineering and IT, and we had a collaboration with Sarah and Enzo, looking really at data-driven insights across the campus. And I'll go into a bit of the background and then explain our current AI journey. Yeah, so just quickly to acknowledge the project team, we've got Enzo and Sarah, who are both here today. Also Benny and NCA, who have worked hard behind the scenes from engineering, aren't with us, but also Maz is, and he'll be here to answer technical questions should they arise. So the background is last year we started looking at the different stakeholders across the campus that might want to make decisions about retrofit. We started to look at what data they already access, what data they'd like to access. And I guess we learned a whole lot about it's sort of the ecosystem, and found out that there are stakeholders that already have the data they need. We have really good data about assets if you're in asset management, or we have really good data about replacement value for buildings if you're in insurance, but it's kind of all kept by a whole lot of different groups. And if you're wanting to start to make data-driven decisions about retrofitting the campus, it's not that easy to find it, even though we do pretty well as a uni, and we've got a great digital estates team. And you probably need to use a whole lot of tools like GIS or CAD or BIM, or maybe some kind of asset management software that you don't know how to use. So we took a 5-step process of going, what's existing, what would people like to have, what decisions do you want to make, and then kind of what's the gap, a bit of a gap analysis. I guess we had a few things in mind at the time, which was maybe we could compel the uni to capture more data if we found some gaps. Maybe we could capture some ourselves. Coming from engineering, we've got sort of drones and LiDAR and everything. But I think what we found in the initial kind of pass was it was really more the tools and way of accessing the data. There's a lot of it that's already there, but that was probably one of the big challenges. There's a report available, and I guess we could send it out to anyone who's attending. So that's just been published, that sort of covers the gap analysis and the findings and the methodology that we developed, which we hoped would also be useful to other precincts and areas that are trying to assess what information they might need for retrofit. So I guess we thought we'll try and develop a tool that enables everybody who might be interested in retrofit to just ask plain language questions. This takes out the kind of struggle to find data, takes out some of the issues with, you're right, sometimes people don't share data, but sometimes it's there and we just don't know about it. and it also helps overcome varying levels of skill. So we started to think of a few use cases. What if I could just ask some questions like you see on the screen, and without having a GIS, if I could just sort of start to get some data-driven information back. So we developed what we've called Umami, which is the University of Melbourne AI for mapping and insights, and started to connect it to a lot of the data that Enzo had discovered through the workshops and across the campus, that sort of data ecosystem. So at the moment, we connected it initially to data about energy use, carbon emissions, building age and condition and replacement value, types of rooms, what rooms are used for, locations of tree canopy, size, location, distance between things. So all of that information that you would expect to see in a CAD drawing or in a GIS. And then we started to develop the model so that we could go from, I guess, a plain language query that's not just querying text, but into proper database and spatial queries. So the model that we developed is a multi-agent system, and it's got a number of models that I guess take those words like where, what, how many, and convert them into spatial reasoning, refines the queries, enriches them with the spatial metadata. And then I think from Yang's presentation, most people that are using AI at the moment are also trying to make sure it's not just rubbish in, rubbish out. So the team set up a system where there are a whole lot of agents and they all come up with results, and then they kind of critique each other and judge each other to execute the queries. So this is just a simple example here. I know from talking to Brendan and the team over time, it's all very well to find a good candidate for retrofit, but if there's something like hazardous materials there, that might throw your cost model out of whack. So we sort of started asking queries like, okay, can you tell us the buildings that, you know, maybe have a good replacement value and a bit old, but which ones have hazardous materials? How far away are they from the edges of properties? You know, how easy would it be to get to get those materials out? I'll run a video in a minute, but I guess the first step was just to look at Umami with a number of data sets that we'd found across the campus. It's ongoing development. So this is the first phase. We're going to develop a live sensor data, so links to where people are around the uni, because I guess some of that's not captured in the databases that we already have, but you can get a better idea of the usage of different spaces. We're also wanting to advance the analytics. We have advanced 3D analysis and visualization options in the digital twin that we already have. So we want to be able to allow people to ask Umami some questions and then say, okay, can you give me a fly through, or can you give me, I'd like that data as a graph, but maybe someone else would like to have it as a 3D model. So giving people that flexibility. We're also hoping that by capturing the queries that people ask, we can identify gaps. Maybe people start asking questions and there is still no answer. So that still tells us that maybe that's some data that we need to go and capture. I guess something that would be interesting, but also has to be kind of treated with a bit of trepidation, is once the model has access to the data, rather than specific queries, you could also ask for suggestions. So you could sort of ask the AI, considering all of these things, where do you think would be good candidate buildings or rooms or areas of the landscape for retrofit? So that part of it's sort of quite exploratory, but could come up with interesting responses that haven't come from sort of standard queries. And we started by developing this, looking at the campus, but we also we partnered with the City of Melbourne and some of the workshops to understand what kind of data you would like to look at for a precinct. So once we've put the tool in a production environment, we'd also like to connect to more information that look more broadly at precincts, other vegetation, streetscapes, to help make decisions in those spaces as well. For the campus, also, we have a meeting next week. We'd really like to be able to connect to some of the other great research groups that look at embodied energy and things like Nested Phoenix that look at material libraries, and see, once that's linked to the model and the building information, how you can kind of dig a little bit deeper to ask different questions to drive data-driven insights in those directions. Now, if I play a video, I don't know if everyone will get sound, but do you get? Is the sound on?
Share screen to the video. They're still seeing the slides,
Oh, that's the video.
but on the Zoom.
Oh, sorry.
If that's all right.
Yeah, sorry. Can you?
Yeah. Bear with us one moment.
What if we could ask questions about our campus, without having to find data or access specialist software, and without data analysis skills? What if anyone could explore ways to make the campus more sustainable, or to retrofit our buildings with the help of AI and data-driven insights? Umami is the University of Melbourne's AI for mapping and insights. Umami takes plain language queries and connects you to accurate information about the campus. Umami can analyze data about the university's buildings and rooms, its energy use and vegetation, as well as other data. Umami can give you data, tables, graphs, maps, and even generate code for you to use. Umami gives you custom data-driven insights about the campus.
Umami is a modular multi-agent system that employs several specialized agents to address spatial reasoning tasks using large language models. The process begins with refining user queries and enriching them with spatial metadata, followed by independent solution generation and cross-evaluation by multiple LLMs. A consensus mechanism and dedicated validation agent ensure logical integrity, after which code is generated and iteratively executed with error correction.
Umami is a prototype AI tool. Umami was developed to overcome challenges in improving our campus. These challenges include varying skill levels, accessing and integrating data, and access to specialist software. Umami was also developed to give everyone insights they need, so that we can all work to make the campus more sustainable. This is just the first step. We will further develop Umami by integrating with additional data. We will add live sensor data via API links. Soon Umami will include advanced data analysis and 3D visualization.
We've started by connecting Umami to data for our campus, but we can also integrate with other data about our precincts and cities. By connecting to real estate, planning, transport and census data, Umami can help make decisions about planning and retrofitting our cities and suburbs. By linking to asset and building data, emissions and embodied energy, Umami could also help to decarbonize infrastructure portfolios.
Yeah, so that's probably it from our group for now. It's been a good start, but a long way to go. But yeah.
It's very impressive. Thank you. Thank you very much, Alice and Yang, for both of your presentations. Yeah, it's so many questions coming up. Maybe we just go to the floor here first. Are there any questions around the room that people would like to ask?
Might need to make sure.
Oh yeah.
How people. You have to speak louder.
Yep. No, thank you so much. For Umami, is thermal comfort the future? Like, is that going to have that sort of data as well? Yeah.
So we have a bunch of sensors in Melbourne, and we're hoping to connect to all of those sorts of data. Yes.
And what about the nitty-gritty of like initial embodied emissions and recurring embodied emissions, because I think there's quite a bit of extensive data that we have in terms of building materials, but are we gonna have those
Yes, so the
smaller
idea is
insights?
we're gonna meet with Rob Crawford's group next week.
Yep.
And we're hoping to figure out if there's a way we can start to connect some of the buildings that have more detail to the Epic database, and if we can start to use that as a way of connecting those.
Right, perfect. Thank you.
All right, that's good. There's a question online here from Hasmani. I hope I'm pronouncing that properly. Interesting approach, wondering how you're evaluating the answers provided when the model has come up with a solution. For example, how can you assess the proposed space for bike storage is actually a good response to the user's query? So a question on fact checking, which is a huge question these days.
Yeah, so I think what we put a lot of effort into is making sure that the answer is using accurate data and analyzing that data accurately. Obviously, if you have a database that tells you there's a room that's not used, the more data you've got, if you've got sensor information that can augment it, you can validate it. I guess at some point you might have to walk down there and check, but the model will give an accurate response. It's not rubbish in, rubbish out, if you know what I mean. So we're ensuring it's only using the up-to-date data that the estates team maintains. So and then we're validating the answer. But sorry.
So in addition to that, we have 3 validation process. So each agent will be critiqued by 2 other agents, and their answer will be compared. And in the final step, the best answer will be. So we are not just accepting each answer.
Okay. And do you provide the reference data it came from, so you can
Yes,
actually drill
yes.
down back
Yeah.
into it?
Yeah.
And the other thing, did I see in some of the answers there had like a confidence level, like a 0.85 or a 0.98?
So we have a confidence level for each answer we give, and agents need to give each other a score. And if they do not pass that confidence level, we do not select them.
Yeah.
Yeah.
Okay. Okay, that's great.
We're not saying it's perfect by any means,
No.
but we're taking steps to try and get quality, because I think that's going to be the biggest challenge in this sort of decade of AI, is kind of being able to give certified responses that you can assure the quality of, rather than just a response.
So, Sarah.
Yeah. And folks hear me there? Yes. Thank you both. I guess I've got a question for both of you, but maybe Yang more so. One of the things that I'm aware of through work that our colleague Kirsten Day does on archiving of digital information for buildings. So a lot of architectural firms or engineering firms 50 years ago, their documentation would have all been on paper, and that all went in on an archive and it's there. And digitizing that has been one thing, but part of the challenge for born digital buildings is maintaining that, is the obsolescence of that data and the obsolescence of software, so that you can't actually, a building that might have been beautifully digital in the year 2000, now that digital information it may have degraded, it might not be accessible. There's a whole bunch of issues around access and longevity of data. So just in your presentation, it just occurred to me that you raised the point about AI only being trained on data, say in the last, up to date 2 years ago. So it's not staying right up to the minute. But is it also the case that we end up with actually a very narrow band of data, which is the currently accessible digital data, for training our models and giving those answers? And yeah, because a lot of that digital information is just technically not accessible, does that provide a really kind of dangerous skew because we're looking at a really, in time-wise, a very narrow slice of data that is available. Yeah, it's like a little thin, yeah.
Notice this, even if you do, yeah, but you also should. So, but if you want to point this. Probably should point it. Yeah, I don't think this.
Yeah. Thank you so much, Sarah. I think this you raised a very important question. Actually, I have to admit that if you looking at most of the existing mainstream large language models, they pretty much they train only the online data only. So, but definitely, for example, some of our existing historical buildings, dams, so they don't have digital data at all. So if you go to any, for example, those transport agency so they have design drawings, still hand sketches. So it's like this. So I think definitely I have to admit that this is a danger, but for any specific domains, then in the future, I expect that maybe people can come up a way to convert those existing data into standard computer processable and standard format, so that in the future the learning algorithms and large language models can process, learn, and those data sets. For example, for some existing paper-based drawings, you can use computer vision to extract those things and to regenerate 3D models, or to and also you can possibly generate some standardized maybe ontology models to describe the building relationships and building description sort of thing. But still, I think there's a long way to go. I quite like, Alice, your prototype, but I think still the data we can access is only a small part, but I think there's still a long way to go in the future.
Yeah. And so then, like, Alice, would Umami come back and say, oh, I don't have any information earlier than 2007. You know, you need to go to the archives or something.
Yeah, definitely. I mean, we actually tried to constrain Umami to begin with, because if we let Umami look beyond just our databases, because it wants to please and it wants to answer, it'll try and find something. But in terms of historically, yeah, I mean, it's happy to say, no, I don't know, I don't have that data. And I guess that's where it's kind of helpful in highlighting other gaps.
Presumably, you can also plug it in with the average or expected life expectancy of certain assets.
Yeah.
And it could, even if it only had up to 2007 data,
it could guess. Yeah.
Plug in that.
Yeah.
Life.
Yeah.
But yeah, the accurate figure gets something.
The reason for focusing the short statement is focusing on internal database. So all the data came outside. So we do not share our data with others.
Yeah.
And we are running some of our LLMs internally, not externally, so no one can see what we are doing.
Can I just maybe finish on a couple of points on that same question? One is from Adam online, who's made the point that data provenance for the lifetime of a project is going to be really important. You know, how did it function? You know, the people involved with the building project, how they interact, and you know, how did it change over time in a dynamic environment, which I think is a good point. The other question I have is, did either of you develop a feel for what was the best information that came through AI? Is it specifications, or is it drawings, or is it, and the reason I ask is, should we be producing different types of information with building documentation now that's going to make AI better in the future? Like, should we be sitting down and interviewing and transcribing the interviews with the lead architect and the lead engineers on projects? Or
You're probably better to answer that because yours looked more specifically at.
I can,
Sorry.
yeah, I can, or possibly I can maybe using, because my laptop is on. I think I can just answer this first, and then I think it's very great point, Brendan. I think technically nowadays, if you think about a building information modeling, according to the Building Smart, which is the international association which develops the open BAME format, which is the industry foundation classes, IFC. So there is also some recent development of developing the ontological IFC, which is kind of combination of the human, the knowledge and also knowledge models, and also the traditional data models. So I think technically you can make everything like well structured and standardized. But if you're looking into the real world, people are still using different ways to create our building design models, and then for different level of information, different details, and some, for example, some people describe the same element, a curved element, as a wall or as some other things. So I think in the future, I think it's very difficult to standardize the data itself, but the only thing we have to do is to improve the flexibility for the model itself, and also to enrich our training data set to make the AI more powerful to process the different data formats designed by different people. So I don't know, Alice, if you anything to add on that.
yeah, I mean, I think you're probably right. I mean, that should be one of the advantages of AI. It should be becoming more and more flexible and dealing with huge, chaotic pools of information. Okay, and so I might quickly go to what's on. That means I need to sort of plug in the HDMI. Hang on. And I need to share my screen.
Yes.
Yeah. I can't tell what I'm sharing here. Is that
Nice.
okay? Are people seeing that online as well? Okay, just what's happening in Retrofit around the traps. So this is the last week for the Retrofit exhibition, so the people here can have a bit of a wander around. But yeah, if you're online, it's open 10 till 5 on weekdays. It's been a fantastic exhibition. It's been really well pitched and well received, so it's worth coming in and having a look around. You've got Wednesday, Thursday, and Friday to do that, and then it starts to be taken down. I just wanted to thank the Retrofit team who put it together, because it has been a big success. But I really wanted to thank Enzo in particular, because not only does he get involved in research, but he's been making sure all of these events run very smoothly, and right down to taking photos and people's names at the front door. So thank you very much. It's been a really positive thing for MSD. Interestingly, the Class Action Housing Commission towers is being appealed, which is good news. So you'll remember it got to the point in the courts where the lawyers were requesting the reports on which the basis of the knocking down of the towers was going to happen. And the government argued cabinet privilege on those documents. And when it went to a judge, the judge actually agreed with that. And so they said that the public could not get access to the reports on which the basis of knocking down the towers was made, which was really disappointing and really didn't leave anywhere for the court case to go. And even more disappointingly, the government, I think, was seeking costs from the plaintiffs for the class action, which is not really in the spirit of government, I would have thought. Anyway, so Inner City Melbourne Legal are appealing that decision, and if you're interested in attending, I'm going to go along. The hearing is set for the 27th of October, Red Court up in Lonsdale Street in Melbourne. Just a note there on the parliamentary inquiry that happened. That was a really good process. We at the Retrofit Lab gave evidence in the hearings, as did RMIT and other groups as well. The transcripts of all of the hearings that were made, you can go to that website there. You can even just Google parliamentary inquiry, go to the housing towers inquiry, and then actually zero down into the transcripts of what was said. And I listened to some of the stuff in the afternoon, and it was really emotional stuff. Even the people on the panel asking the questions were getting teary, listening to the experiences of the tenants and the tenants association. So it'll be really interesting to see what that report says in December when they hopefully produce it. And the last one there is the Digital Estates for Zero Carbon Building Portfolios report. So that's now open and live on the Retrofit Lab website. So log on and have a look at that. So we've heard a bit about that today. That's it for the formal stuff, but there was one other question I wanted to ask Yang. What's our timing? No, we've got 3 minutes, Yang. In 3 minutes, I was wondering if you could maybe just give us a bit of an insight or a feel for what's going on with Retrofit in New Zealand as opposed to Australia. So, and I'll preface that by just saying our housing minister here in the parliamentary inquiry actually got up and said that retrofit is not a global movement, which is to me at best ignorance and at worst telling untruths. How's retrofit in New Zealand at the moment?
Thank you so much, Brendan, for asking this. I think in New Zealand, it's still a lot of retrofit projects are happening at the moment. I think it's definitely it's a global phenomenon. So because after the Second World War, we have built millions of buildings in US, Europe, and New Zealand and Australia. So in New Zealand, we are I think what we have is a lot of natural disasters and earthquakes and much more earthquakes than Australia has. So still a lot of seismic strengthening projects and also repairing those leaking projects, and also what I presented in my slides. So there have been a lot of upgrade of the existing buildings and so on. New Zealand is a small country, so I feel sometimes the practitioners, they are also learning from UK, from Australia as well. But definitely, I feel for seismic strengthening, so it's definitely leading a lot of the best practices in the world.
I was going to say, I think Australia has a lot to learn by looking to New Zealand and maybe other places, San Francisco, Japan, for seismic strengthening methods. And in fact, the independent studies that were done on the Housing Commission towers, I think structural engineers who came up with the seismic strengthening schemes were actually from New Zealand. So it's good to have you over there. Many more natural environmental dangers, less dangerous animals.
Yeah.
All right, I think that's our time. So thank you everyone for coming along, and thank you for logging in, and in particular thank you to Yang and Zen for flying all the way over. Alice and Maz, thanks for coming along. I think I learned a lot. It's a really good discussion. I'm really excited to see where it's going to go. Okay, so I think we've got a September forum lined up, which we're still organising, but please keep your eyes open on your email, and there'll be communications come through on that, and we'll convene on the last Tuesday in September, I believe. Okay, thank you very much.
Thank you so much.